dear students, I welcome you all for the course Control Systems. In this particular session, we are going to discuss about the response of the second order system. Especially in this particular video, we are going to discuss about the response of the underdamped case when we apply the step input to the second order system. So why it is called as underdamped? Because the psi value lies between 0 and 1. Our objective is to compute what is C of t. C of t is nothing but the response in the time. As you all know, the standard form of the closed loop transfer function is C of s by R of s is equal to omega n square divided by s square plus 2 psi omega ns plus omega n square. In the last session, we discussed about the transient response, steady state response, and also I have introduced the concept of second order system to you, and we discussed the roots of the second order system. Because this is a second order system, there are two roots. In this underdamped case, the roots are complex conjugate. Omega n is a natural frequency, omega d is a damped frequency of oscillation. Now from this I am going to write the response in an S domain, which is nothing but R of s into omega n square divided by s square plus 2 psi omega ns plus omega n square. You know that you are going to give the input as unit step R of t equal to 1, so R of s equal to 1 by s. Now this C of s can be written as 1 by s. Why it is 1 by s? This R of s is nothing but 1 by s I have written here. And omega n square divided by s square plus 2 psi omega ns plus omega n square. Now I am going to apply the partial fraction expansion for this particular case. So I am going to write like this: a by s plus bsc plus c divided by s square plus 2 psi omega ns plus omega n square, because here the roots are a complex conjugate for this particular polynomial. So I can write s square plus 2 psi omega ns plus omega n square with respect to bs plus c. Now you have to compute a. A can be computed using C of s into s. S tends to 0. You are getting a equal to 1. To compute the BC, just you take the C of s omega n square divided by s into s square plus 2 psi omega ns plus omega n square, which is equal to, you computed the residue a, you substitute here, so it becomes 1 by s plus bsc plus c divided by this term. Just to do the cross multiplication, you will get the term like this: 1 into this term you are getting here, from this to this one. Then bsc plus c into s becomes bsc square plus cs. This denominator gets cancel each other, so your term becomes omega n square equal to s square plus 2 psi omega ns plus omega n square plus bs square plus cs. Now to compute the b, just equate the s square coefficient. Here the square coefficient is 1, here the square coefficient is b. So your expression becomes, you see this one, your expression becomes s square coefficient 0, because LHS there is no s square, so 0 is equal to 1 plus b, from which I can compute b equal to minus 1. Similarly, equate the s coefficient here 0. S coefficients are 2 psi omega ns plus c. So I can compute c is equal to minus 2 psi omega n. You substitute a, b, c in this expression, you will get 1 by s minus s plus 2 psi omega n divided by s square plus 2 psi omega ns plus omega n square. Now we are doing a simple calculations here. What we are doing here is just add and subtract omega n square, that is psi square omega n square, to the denominator in the second term, this term. So you are going to add the psi square omega n square, you are going to subtract the psi square omega n square. Now you are going to combine the square 2 psi omega ns plus psi square omega n square. Your term becomes s square plus 2 psi omega ns plus psi square omega n square plus this balance term omega n square minus psi square omega n square. Okay, this becomes a plus b the whole square. I have written here, you see, s plus psi omega n the whole square for this one, plus you take omega n square outside, you will get 1 minus psi square. You know that omega d can be written as omega n square root of 1 minus psi square. So what is omega d square now? Omega d square is equal to omega n square. You take the root, it becomes 1 minus psi square, the root gets cancelled each other. So this term is nothing but omega d square. That's why I have substituted here. Now you take this one 1 by s. Here you are having 2 psi omega n. I am splitting this as psi omega n plus psi omega n. So this is minus 2 psi omega n. This is minus s plus psi omega n minus psi omega n divided by this term, because 2 psi omega n you take, the denominator is common. So when you split also you should use the same denominator. Now we are going to multiply and divide omega d in the third term of the denominator. So 1 by s you keep as such, the second term you keep as such. In the third term you are going to multiply omega d and divide omega d here. Now we are going to apply inverse Laplace transform. So you know that when you take the inverse Laplace transform of 1 by s, it becomes 1. I'll tell you the concept here. So if you take the Laplace transform of e power minus at into sine omega t, suppose you are having the term like this, then the Laplace transform is omega divided by s plus a the whole square plus omega square. Similarly, the Laplace inverse of e power minus at into cos omega t you take, you will get s plus a in the numerator divided by s plus a the whole square plus omega square. So use this term to compute the inverse. If you take inverse of this 1 by s, you will get 1. I'll show you. Then you take the second term, s plus psi omega n divided by s plus psi omega n the whole square plus omega d square. As I already told, this is like e power at cos omega dt. That's why you will get s plus a divided by s plus a. You compare this and this. Now you can write it as e power psi omega nt here, e power psi omega nt cos omega dt. Then here you keep omega d divided by s plus psi omega n the whole square plus omega d square. This you can compare this with this one. So you will get this psi omega n divided by omega d, it is available here. Omega d divided by s plus psi omega n the whole square plus omega d square becomes e power minus psi omega nt into sine omega dt. I hope you are clear with this. Now you are going to take the e power psi omega nt outside. You will get sine omega dt. I have taken minus outside, so it becomes plus psi omega n divided by what is omega d, omega n square root of 1 minus chi square sine omega dt. This omega gets cancelled each other. You do the cross multiplication, take square root of 1 minus chi square outside. So you will get 1 that is square root of 1 minus chi square into cos omega dt plus psi into sine omega dt. Now you can use square root of 1 minus chi square and psi to construct this right angle triangle. You see this, we have constructed the right angle triangle with the psi as an adjacent side and square root of 1 minus chi square as an opposite side. Obviously your hypotenuse becomes solved here. It becomes adjacent square plus opposite square. You will get the value as 1. That's why I have entered here. Now I am writing sine theta. Sine theta, how can I compute sine theta? Everyone knows it is opposite by hypotenuse. Opposite is square root of 1 minus I square divided by hypotenuse is 1. So cos theta, how can I write? Cos theta is nothing but adjacent divided by hypotenuse. So psi divided by 1 becomes psi. Now I am writing tan inverse. It is nothing but opposite divided by adjacent. So square root of 1 minus psi square divided by psi. Now you apply this concept here. Okay. Instead of square root of 1 minus psi square, I am going to write sine theta. Instead of psi, I am going to write the cos theta. Now my term is, you see this equation, 1 minus e power minus psi omega nt divided by square root of 1 minus I square sin omega dt. How this sin omega dt comes? This term I have taken sin omega dt into this side. Psi can be replaced by cos theta. Then cos omega dt square root of 1 minus I square can be replaced as sin theta. Now you take this one, sin omega dt cos theta plus cos omega dt sin theta. It becomes sin a cos b plus cos a sin b. The formula is sin of a plus b. So c of t can be written as 1 minus e power psi omega nt divided by square root of 1 minus I square. I am taking this term. Instead of this one, I can write it as sin omega dt plus theta. How can I compute theta? I know what is a tan theta. I can compute the theta is equal to tan inverse of square root of 1 minus I square divided by psi. Now I am going to show how the response of the system. So as we already seen, this is the input to the system. This is a step input we are applying to the second order underdamped system. Your response will be like this. So I hope we already studied that. You remember, this particular response has two components. One is called as the transient response. The another one is called as steady state response. We already discussed what's the transient response and steady state response. I hope you are clear with this topic. The rest of the topic we'll discuss in the subsequent lectures. Thank you.